Hi everybody, I'm Professor Rad, and today we're going to talk about hypothesis tests. So a hypothesis test is a technique that's going to apply the central limit theorem. So that's going to be our first blank that we fill in here. And the hypothesis test is a way of testing a claim to see whether it's true or not. So this might be something like somebody tells you that, oh, hey, did you know that the average temperature in New York City is 75 degrees Fahrenheit? So you might hear that, you might think, really? I always thought it might be colder than that. Or maybe it depends on the time of year. Maybe if I'm looking at the whole year, maybe it's warmer, maybe it's colder. That seems a little suspicious. Or maybe you hear about a new medication that claims to reduce the length of the flu by 2 days. So you might be wondering, well, how do they know that? How do they know that it's going to reduce the length of the flu on average by 2 days? So in those situations, you can conduct a hypothesis test. The null hypothesis is that statement that you hear or that somebody tells you or you read, or it could even be like an assumption of something going on. So that could be someone saying like the average temperature in New York City is 75 degrees, or, oh, this medication will reduce the length of the flu for a mean of 2 days. So just like you can create a confidence interval for different kinds of values, like a mean or a proportion, you can also do that for a null hypothesis or for a hypothesis test. But for our class, we will just be creating hypothesis tests for the mean of a population. So our null hypothesis, that's what this H0 stands for, the null hypothesis, will always take the form that the mean is equal to some number. By the way, I don't know if it's picking up on the mic, but there is a thunderstorm going on at the moment. So if you hear some rumbling, hopefully that's on the recording and not where you are. But don't be scared. It's all good. It's just mathematical ambiance. So our null hypothesis is this claim that you hear or you read, and it's always going to be like mu is equal to something. So the mean temperature equals 75 degrees. The mean reduction in length of the flu is 2 days. Now, when you hear a claim like that, you might be suspicious of it. You might think, actually, maybe the temperature in New York City, on average, if I look at a whole year, maybe it's less than 75 degrees. That seems a bit warm to me. Or, really, I took that medication and it reduced the length of my flu, I would bet, by like a week. So maybe it reduces it by more than 2 days. Or what's more likely happening in a clinical trial is they're testing, is it the same as the other drug, right? Is it the same or different? So what you suspect might be going on, that's called the alternate hypothesis. And the alternate hypothesis takes one of 3 forms. It's a left tail, a right tail, or a two-tailed test. In the left tail, you think the mean might actually be less than the claim. So this would be like, I suspect the mean temperature in New York is less than 75 degrees. Maybe over the course of a year, it's a bit cooler than that. A right-tailed test would be if you suspect it's more than what's being told to you. And a two-tailed test is, we're going to use a not equals to, and that's you suspect it's different, but you're not quite sure how. So in a test for medication, for example, what they might have done is they might have said, okay, under the old medication, the flu lasted 7 days. And for the new medication, we suspect it's going to be different. So we suspect that it's not going to be 7 days. Maybe it'll be less, maybe it'll be more, but we're going to test that to find out. These numbers that you use in your alternate hypothesis are the same for the null, which is H0, and the alternate, which is H1. Okay, so we're using H1 for alternate. Some textbooks use HA, okay, ha ha ha. But we don't have joy here in math, I'm kidding. But we're gonna have H1 for our alternate and H0 for the null. And again, whatever number I use for the null hypothesis is what I'm going to use in my alternate hypothesis. And typically when you conduct a hypothesis test, your suspicion is going to form a single alternate hypothesis. But how we know which one to use can be a bit tricky. So I've got an example of 3 people forming hypotheses, and we will use it to, we're going to create 3 alternate hypotheses just to see what might clue in a different formation of the problem. So in this example, Alice, Ben, and Carol are studying changes in temperatures in the Northern Hemisphere. Alice suspects that a global warming is occurring, and Ben thinks it's actually a global cooling. Carol isn't sure how the climate is changing, but she thinks it's changing somehow. So the 3 of them work together to find the mean daily temperatures for 1950 and for 2010. And they record the difference between the 2010 and the 1950 daily temperatures. So what this means is that all 3 people are going to have the same null hypothesis. So they think that temperatures are changing. They might have different suspicions about how those temperatures are changing, but they all believe the temperatures are changing. So what they're contesting is the thought that temperature's not changing. So their null hypothesis is that mu is going to be 0 degrees Fahrenheit. Here's where I got that from. So they're recording the difference between the 2010 and the 1950 daily temperatures. So if there has been no change in temperature, then the difference between them when you subtract them would be 0. So the null hypothesis in this case would be the status quo. Nothing has changed. There is no change in temperature. Now let's see how they might form their alternate hypotheses based off of their suspicions. So we're going to look at Alice first. It says that Alice suspects that a global warming is occurring. In other words, Alice thinks that temperatures in 2010 are probably higher than the temperatures in 1950. So when you subtract the 2, you're taking a bigger number minus a smaller number, so you're getting something bigger than 0. So Alice's alternate hypothesis is that the mean temperature change is more than 0 degrees. Ben thinks it's actually a global cooling, so he thinks temperatures are decreasing. So his alternate hypothesis would be the opposite direction, that the mean is less than 0 degrees. You're taking a smaller number from 2010 and subtracting a bigger number from 1950, so the temperature would be less than 0. And Carol here has an alternate hypothesis of, let's see, what does Carol think? It says Carol isn't sure how the climate is changing, but she thinks it's changing somehow. So basically, she just thinks it's different. It could be greater, it could be less than, but she thinks it's different. So in this case, Carol's alternate hypothesis is that mu does not equal 0 degrees. All right, I've got a couple practice problems that I want to look at as well. So let me pull those up. I'll be right back. Okay, so if you're following along in your workbook for our class, I've got this on page 326. And so we've got a few practice problems here, and we're going to practice the null and the alternate hypotheses. So in this first question, it says, a study claims that college students own a mean of 6.9 technological devices, like laptops, smartphones, and so on. But Karen thinks that students own fewer devices than that. So she conducts a hypothesis test at the O1 level and finds a p-value of 0.0094. Okay, we haven't talked about that last bit yet. We'll talk about that in the next video. So on this one, I just want to focus on the null and the alternate hypotheses. So the study claims that college students own a mean of 6.9 technological devices. That's going to be our null hypothesis. So the null hypothesis is that the mean is 6.9 technological devices. Karen thinks that students own fewer devices than that. So her alternate is that the mean is probably less than that. That's her suspicion. Now, since she thinks that the mean is actually less than 6.9 devices, she's conducting a left-tailed test. If she had a greater than, then it would be a right-tailed test, and a not equals to would be a two-tailed test. All right, so let's go ahead and look at another example just to practice this. So here in question 2, it says, a nutritionist examines a simple random sample of 30 adults to determine if they eat, on average, more than the recommended daily amount of 2,000 calories. And then the rest of this we haven't talked about yet, so I'm not going to worry about it. We just want to state the null and the alternate hypothesis. So for the null hypothesis, you want to think about what is the claim or what is the statement that the nutritionist is contesting. So it looks like she's wondering if adults eat on average more than the recommended daily amount. So the thing that she would be contesting is that adults are eating the recommended amount. So our null hypothesis is that the mean amount of calories that adults consume is 2,000 calories. She suspects that they're eating more than that. So the alternate hypothesis would be that mu is greater than 2,000 calories. And that's going to make this a right-tailed test. I just realized I forgot to write tail in here. All right, so I think that's going to wrap it up for now. In the next video, we will revisit this concept, but we'll also talk about what that other stuff means. So we'll talk about, okay, so you have this claim and this suspicion, so how do you decide whether your suspicion is warranted or not? So I'm looking forward to seeing you then. In the meantime, I hope you have a wonderful day. Bye for now, everybody.